Good afternoon, and thank you for joining today's webinar from Spec Innovations, ISO 26262, the V model, and Innoslate. My name is Taylor Duffy, and I'll be the moderator for today's webinar. First, I'd like to go over some housekeeping. Next slide. During the presentation, feel free to send us questions, and we will get them answered in the Q&A part of the webinar. You can also interact with us on LinkedIn through the Innoslate users group or through Twitter using the handle @Spec Innovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Now, I'd like to introduce you to our presenter, Andy Tapia. Andy is a systems engineer at Spec Innovations and an alumni of George Mason College of Systems Engineering. Feel free to send him any questions through the LinkedIn users group or send him an email to andy.tapia@specinnovations.com. And now I'll hand over the controls to Andy and we'll get started.
All right, thanks, Taylor. Hello, and thanks to everyone for coming out to today's webinar, ISO 26262 V model and Innoslate. So as you heard, my name is Andy Tapia. I'm a system engineer here at Spec Innovations, and I help the continuous development of our flagship tool, Innoslate. And so today, I'm here to talk about how Innoslate can help enable ISO 26262 compliance. And to do that, we're going to go over the following items. So first I want to define and understand the standard itself, and then talk about some of the challenges of its implementation. Then we'll go over our company's tool Innoslate and how everything ties back to the V model. And then after that, we'll connect the dots and see how parts of the ISO standard are supported by our tool's Innoslate's feature set. And then we'll close out with a little summary of how we can see that Innoslate can enable ISO 26262 compliance. So to understand ISO, the standard, first we got to understand the organization behind the standard. And their name is the International Organization for Standardization, which is ISO for short. And ISO is a community of global experts, and their stated mission is to, quote, bring together experts within its membership to share knowledge and develop voluntary, consensus-based, market-relevant international standards that support innovation and provide solutions to global challenges, end quote. And I think from this, we can see that this is a widely respected and influential organization, and that their standards carry a lot of weight in the international community. So down to the ISO 26262 standard itself, it's made out of 12 parts, and they were last updated in 2018. And the topic that it deals with is the functional safety of road vehicles. And using the official website articles I found, I think we can summarize the standard as a functional safety standard that addresses the risks and hazards caused by the malfunctioning behavior of electrical and electronic safety related systems. And I think the ultimate goal of the standard is to minimize the risk of potential accidents and ensure that safety related systems work properly even when a fault occurs. So each of the 12 parts that I mentioned earlier, they contain lots of different guidelines, and that when you combine them together, they make up a tailorable automotive safety lifecycle that weaves into the product development process. And the processes include, it goes from management, development, production, operations, service, and decommissioning. And if you notice, for some of you in the audience, it starts to look a lot like the V model, but I'll come back to that in a little moment. So when it comes to implementing the ISO 26262 standard, there's a few notable common challenges that I think come into play when you're trying to maintain safety in today's modern vehicles. That includes the ever-increasing complexity of these vehicles, which of course demands additional time and cost resources. And of course, managing the traceability of relationships between items during the development process, which can span over testing, validation, and risk management. And then as a last point, I think that there's a kind of a lack of tools to support implementation, particularly at the higher levels, which leads us into the next slide. Yeah, and this is where we start to talk about Innoslate itself. And as a bit of a quick background, here at Spec Innovations, us at Spec Innovations, we're the developers of the model-based, cloud-based system engineering tool Innoslate, which is designed to support the entire system engineering lifecycle. And we're always consistently releasing updates, listening to user feedback to support our digital thread capabilities here. I know that we're on version 4.9 right now. I believe that released either last week or 2 weeks ago, and it's got some new features like latex and a new UAF dashboard. And another important point I want to make is that in combination with our software developers, a lot of us here are system engineers, and as we're helping improve the tool, I think we can consider this tool to be made by system engineers for system engineers, which makes it pretty neat. But don't worry for anyone else who is not a system engineer. This tool was designed using the lifecycle modeling language, LML, and that language's goal was to be able to include more stakeholders beyond like us SE experts into the SE lifecycle process. Like I know with SysML, some of the terminology gets pretty dense, and some of the terms and jargon can be lost on someone who's not involved in SE to begin with. So, as part of supporting the system engineering lifecycle, Innoslate is designed to enable and support the classic V model process, and this is our version that I'm showing right here. This is a staple in the SC community. Everyone recognizes it by the V shape, the classic V shape here, and how it walks through system development. And it's covering topics such as current operations and maintenance, architecture development, system design, hardware, software acquisition, integration and tests, operational T&E and transition, feature operations and maintenance, and demolition and disposal, all under the umbrella of careful program management. So now we'll come back to that idea that I wanted to revisit. So the similarity that the standard had earlier, surprise, it's not a coincidence that they were similar, because the ISO 26262 standard was actually developed with heavy references to the V model process. And the V model, for those that don't know, the V model is relied upon to ensure quality and efficiency during system development. And as we saw earlier, it's made out of a combination of technical and programmatic processes. So naturally, the main parts of the standard would fit into this process pretty neatly. I think that's because the goal is to have safety baked into the SE lifecycle process, and not have it bolted on at the end or tacked on some random point in the process. It's best to have it from beginning to end too. Yeah, and here I've just taken the liberty of kind of mapping some of the main parts to our version here of the V model to see how it flows. Mainly follows the same visual that we've seen before, that we saw on the last slide. Yeah. And then when it comes to Innoslate, as I said before, our feature set is by design well aligned with the V model SE lifecycle. So each of our features does play a role in the V model. That includes things like our project dashboard views, documents and diagrams views, modeling and simulation capabilities, even some of our design tool integrations and test center, among other things. And so because the V model is kind of the existing in an overlap between these two topics, we can put the ISO 26262 and Innoslate side by side. And once we do that, we can see that we can map a lot of the functionality of the standard to Innoslate's feature set here. And so from this point onwards, I'm going to go through how we mapped the functionalities to the features, and I know we have a white paper about it that has a link to a more detailed spreadsheet version. And because of the constraints of time, I'm mostly going to go over the main parts that I think will come up. in these functionalities. And I'm going to use the vModel process phases to make it easier to understand. So I'm going to walk through from the beginning to the end. So first we have the program management phase here. And on the ISO side, I think there are certain elements I picked out that I think would synergize well with Innoslate's features. So we can see in part 2, we have the management of functional safety. And under that, we have more elements here: overall safety management, project-dependent management, project-dependent safety management regarding production, operation, service, and decommissioning. And there's a couple sections of part 8, supporting processes, such as the interfaces within distributed developments, specification and management of the safety requirements, change and configuration management, verification, and documentation management. And I think Innoslate's really well suited to starting up projects from the start, and it gives you the controls and the ways to keep track of people on your team, assign tasking, and you can do this even from remote locations thanks to our location in the cloud, either different spots across the nation or in your supply chain. And another thing is you're able to plan activities using our diagrams view, and you can manage documents using our documents view. And I'm going to expand on that in the next few slides here. So I have a couple of case studies. I call them case studies here, but these are actually all from our sample projects that you can download freely during the guided tour of Innoslate. I believe it doesn't matter if you have a free or paid version, that you're able to just download them and have Innoslate walk you through them. But all these case studies are come from that. And so this one in particular comes from our autonomous vehicle project. And that's what I'm going to use to show how our project management dashboard works here. Very appropriate. And so now we're looking at the dashboard. Here we can see a calendar. It gives us a visual of the upcoming events and the dates. You have a visual of important diagrams and tasking there on the upper right, with the work breakdown structure there. And you have a board progress chart on the lower right there. But you're not limited to this at all. These are all widgets, and you can add more views if you'd like using the add widget feature. I don't remember all of them off the top of my head, but I know that there's some like change requests. You can see what's being changed on during the progression of the system. And you can just customize it to whatever you need and whatever your priorities are. If you want to look at a certain thing every time you log on, I think it's pretty neat. So then in here, we have a case study from our lunar rover sample project. And here's a snapshot of the documents view and a screenshot of the action diagram on the right-hand side. Looking at the documents view, you're able to set up all of your important documents, such as the project management plan, but you're not left alone to build it from scratch. We have a lot of pre-built templates for you to work with. And we also have a digital curation station that has more standards beyond that, some specialized ones. And this one in particular, this template was built using NASA's program and project management plan template. And that helped us get started pretty quick when we made this project. And clicking into the right side, we have the action diagram. It's actually an executable. It's executable, and this is a view of the project plan in action diagram format. Here you can lay out your high-level tasking here, figure out what needs to be done, what goes in, what comes out, such as deliverables. And a cool thing is that you can convert this view into other views, such as the timeline diagram, and that's thanks to the LML specification that we follow. So here we have the example of that timeline diagram, which gives you more of a list view of the tasks to be completed, has that progress bar kind of built in, and you can also put up some milestones for the project there. They would go underneath where that calendar bar is on that left-hand side. And on the right side, we have the Kanban board that we have, and you can interact with that. It's interactable, so you can see the daily progress every day when you log on, or just continue the progress of tasking throughout the project. So you can move the tiles around as you need to. It's all customizable. And in the same project, we also have an intelligent dashboard. And this is one good way of maintaining project quality during development. It's pretty powerful. And that's because the intelligent dashboard, I believe it automatically runs, and you can also set it to run manually too. And when you do that, it's automatically measuring up to 60 heuristics to make sure that your project is quality. And the way it does that is by checking for things like duplicate and orphan entities. Um, Maybe you have some things that are named the same way, or some entities that are just sitting around, not connected to anything. So the dashboard will put a red flag on that, and you'll see that highlighted, and you can choose whether or not to get rid of it or not. And another thing that it checks that's pretty powerful is it requirements analysis. It'll check to see if things are connected properly. If it has a satisfying feature, you want all your requirements to be satisfied ideally. And but the main thing I think that you get from the dashboard is to make sure that all the relationships are connected to each other properly, that everything's complete, so that way you don't have any loose ends, or you don't have to manually look for any loose ends that you have to tie up uh, later on. So next we have the architecture development phase, and I picked out a few elements here from part 3, the concept phase, and part 12, the adaptation for motorcycles. And in these elements, we see that the standard has guidelines for the item definition. So for breaking down a item, it can be an airbag or such, combined with a car, HARA assessments, and the functional safety concept. And yeah, from what I understand, we're making sure to recognize that the system under development is interacting with other components during development, and that we're performing HARA assessments with regards to the severity, exposure, and controllability, and that we're using the functional safety concept to derive functional safety requirements from safety goals. And to meet these elements in the standard, I think Innoslate is able to provide the support by providing some of the different diagrams that we carry. In particular, that would be the asset and risk diagrams. And there's also our requirements document and the test center suite to handle the requirements and their verifications later on in development. So returning to our autonomous vehicle sample project, here we have a screenshot of how the requirements are laid out in a requirements document. And so with the requirements, you can freely organize and label them. You can denote their specific type, such as if they're a functional, if they're a performance requirement, or any other label you need. You can make your own labels, label them by priority if you need to. And as you're writing the requirements, they can also be checked by the quality score checker, which you'll see in that column there, quality score with the 75% in the green bar. And I think that one is especially powerful because as you're writing your statement and you publish it, it uses natural language processing to check against some of the more common requirements writing heuristics used by organizations like INCOSE, such as not using ands, not having commas in there, and making sure that you're using unambiguous language. So it kind of forces you to write good requirements from the start. And another neat feature is that you'll notice there's green text in the upper right corner of some of the requirements entities. You see an S and a V. The S stands for it being satisfied by another entity. For example, a certain asset or certain action, but not limited to those type of things. And V for verified by another entity. For example, a certain test case, which we'll get to soon. Here we have another diagram view here. spider diagram, and that allows us to see all the relationships between a central entity and others. And I think it goes up to 3 levels, as far as I believe. And it'll show you all the relationship types, including but not limited to decomposition, sourced by, satisfied by, verified by, and lots more. And these are all derived from the LML specification as well. So you can kind of see what led to the creation of a certain element, or how it's connected to other objects in a project if you ever need to. Help you make decisions and understand the reasoning behind decisions too. So here next we're looking at the Lunar Rover project again, looking at our asset diagram, which can be used to build ConOps by defining your system boundaries and the external systems involved in potential solutions that you're coming up with. You can make simple connections. But you can also have directional, bidirectional arrows, and here we have a background image set. You can upload a background image to make it more realistic, or to get you in a better state of mind when you're coming up with the um, asset views here. And another neat thing is that you can put these diagrams directly in the comments that you're creating. It doesn't have to be a requirements document, but it can be any type of document. And inside the documents themselves, we do follow the concept of concordance. So that way, if you're changing the diagram in any way, if you ever need to change it, change some text, or the way things work on it, it's automatically updated and refreshed inside the documents that are referencing the diagram. So that way you're not really chasing down and rebuilding different diagram views and different documents. So it takes care of that unnecessary work for you. And the next we have, here's an export of our risk diagram from that same project. By default, it comes in a 5x5 chart, and by default, it also has a risk probability on the left-hand side and severity of the consequences on the upper right. And from there, you can place your risk entities inside, so you can have a visual representation of the different levels of risk too. And in this project we had, right now it's showing some technical risks, but you can also apply them to project level risks. So you can go upper or lower as you need to. And you can, in fact, modify them to fit what you need. So as I said before with functional safety concept, or no, the HARA assessments, you can change it to meet that standard um, by severity, exposure, controllability as you need to. And it doesn't need to be in a 5x5 either. You can change that as well. And I believe color too. That's all modifiable. And here, following the risk diagram, we have a risk burn down chart, and that'll show you the probability of risk over time. So as you're going through your project, as you're mitigating your risks at different points in time, every time you do that, every time you're mitigating a risk, that's represented by a point in the line. And a person once they're mitigating something, a person will be able to change the risk probability number by a certain amount as desired to show that you are reducing the risk of risk probability over time. So now we're moving on to the system design phase. And as expected, we can see that there's lots of different ISO guidelines being pushed here at the product development stages. You have the system level, hardware level, software levels here. We also see the technical safety concept, which goes into more detail than the functional safety concept with its requirements. That's where you'll start to see requirements being written for detections, for indicators, indications, and requirements for controlling faults. And we're just gonna keep building on the features that Innoslate can provide. Some of the ones I think that are particularly helpful would be the ability to convert between LML and SysML diagrams, some of our interface control diagrams, our simulator view, the CAD viewer, and the traceability matrix. I think those ones are pretty important. So here we're walking into our fire sample project. And as I said before, while we do work with LML, we are able to convert between LML and SysML diagram types because they kind of have a similar concept behind the views. And we have an example here, the state machine diagram and the use case diagram. Here, state machine, you can create your safe modes, you can create your degraded modes, uh, and in use case, you can create your user stories to help you evaluate safety scenarios and develop your documentation using these CSML methods. Then beyond that, we have the interface control diagram. This one's a bit of an older picture, but it's still about the same as what we have right now. And that allows you to visualize and connect interfaces of assets with conduits. You can put conduits between the assets, interfaces, and then from there you can define the types of inputs, outputs, latencies, and the capacities between them. So you can start to see that, build insights. And then from there, we have our simulator view. Um, so if you remember what I said before about how those action diagrams are executable, this is what you get when you execute them. And once you execute them, the actions and their constructs, they can provide you information about things like durations, resources, whether it's going up or down, data flows, and you can discover unexpected system behavior using this tool. And a really good thing about the action diagram is that every action entity and construct that's used inside the diagram, under the hood, you have a script API, so you can insert some of your own JavaScript code to further its functionality. You can add in your own methods, functions as you need to. Um, and when you do that, you can do neat stuff like printing out messages here you can see on the console. And some of that allows you to run our integrations, such as with MATLAB and SDK too. So here we have a couple screenshots of our CAD viewer. And from here, you can use your STL and OBJ files to look at the system or the subsystem parts as they're being designed. And a neat thing is that if the files have label information, you can have it show the different parts and also create an asset diagram directly from the file, so that way you can get up and running a lot faster. And then here we have an example of our traceability matrix here. And that's accessible by using a parent entity, such as a parent requirement, and then selecting another parent entity and filtering for the types of relationships between them. So you can filter for things like satisfy, verified by, trace to, for requirements especially, so that you can keep track of how well those requirements are being developed and being completed as you're traveling throughout the SE lifecycle. So then moving on to the hardware and software acquisition phase, there's a couple of guidelines involved in the confidence of use of software tools, the qualification of software components, and the evaluation of hardware elements. And because these involve more evaluations and analyses, I think the documents view again can be helpful here. And I'll show you how we use that in the next slide, right here. So another way to use Documents View beyond creating plans is to record information of all kinds. So for example, in the Lunar Rover project, we recorded our design evaluations and the analyses here. It helps you create and maintain a record of work, support your decision making throughout the project. And a good thing is that if you do create these sorts of documents inside of Innoslate, you can actually relate them to other entities within Innoslate under the LML specification, and that'll kind of give you a traceable record behind things like certain decisions or certain reasonings for certain actions. Yeah, and for better or for worse, you can trace that and see who did it too, who done it. So then moving on beyond that, you can also use it to record notes For example, from the research phase, maybe you're doing research and doing summaries of articles you're reading, recording sorry, recording meeting minutes, or even a bill of materials, like you see here. And next to that, you have a hierarchy chart. As an example, you can use that to record the different subsystems and the components as they're being built out and developed. So you can keep track of everything that's going into your system, which is pretty useful. And then here we're going into the integration and test phase. And here the ISO provides some guidelines for performing the integration and verification testing at all the different system levels, again, hardware, software. And here we have some tools in particular that I think can help support that effort, namely our GitHub integration and Test Center itself. So we return to our Lunar Rover project here, and we have an integration, a GitHub integration that led to us having a repository dashboard where you can work on software components that, as you're working on them, they're reported back to Innoslate with GitHub. And any issues that arise during development then can then be you can create issues, and solutions can be collaborated upon with comments here. And one thing I should have included is that there's also a repository overview dashboard, and that shows you kind of more statistics type stuff. So you can see things like active pull requests, active issues, recent issues, and some commit statistics there. So you can work on software, some software components here within Innoslate. Okay, and then next we have a look at Test Center itself. And that lets you create sets of test cases to either verify your requirements or perform evaluations of certain components of your system. And inside every individual test case, you can outline your expected results, record the actual results, and the status of that test case. So it can be passed, failed, not run, or in progress. And once you do all that, you can roll them up. So you get the higher level items, so that way someone going through can kind of get a quick overview of what's happening, what's going on with different sets of tests. Okay, and then here we have the operational test and evaluation and transition phase. And here the ISO standard is focusing on the safety validation of the vehicles here. And I think in Innoslate this is still supported by what we brought up earlier, the requirements document, your documents view, traceability matrix, and test center again. So we'll go back to the test center here with the FireSat project, and you can adapt these test cases to be more oriented towards validation activities. You can see here in the project here, we're creating multiple acceptance tests, and you can say we're checking for stakeholder validations and how they're related, which can be related to the requirements and other documents inside the project. You could also create your own labels to differentiate them so you don't get lost too. Have it more clean in the database. And then we have the future operations and maintenance phase here, where the standard is giving guidelines for the planning and production, operation service, and decommissioning. And here I think that includes the planning documents that you can make within Innoslate, as we said before. I think a feature that could help here is that those types of documents are exportable in different formats. You have Word, XML, and there's a bunch of others too. To have your data more mobile once the project is finishing or is being delivered, so then it's still somewhere. And in fact, with the diagrams too, they can also be exported. It takes a little bit more effort, but you can also export the diagrams as either INO or XML files. And if you just need the visuals too, you can also export them as PNGs or JPEGs or vector graphics if you ever need that. It's possible. And then here we have the demolition and disposal phase. And I think that's the same approach as before, where The project planning files, deliverables, diagrams can be exported and preserved on in the cloud. You have that option. You can download it or export it to your hard copy, make those local hard copies, or keep it on the cloud. And yeah, I think that kind of brings us to the close of all this. So to kind of summarize everything so far, I think Innoslate really is in a position to enable easier standard compliance because it does empower your safety compliance, lets you easily perform project management, maintain your safety risk awareness, preserve your safety analyses that you do, ensure continuous traceability throughout the lifecycle, quickly maintain your documents and diagrams, and enable easier engineering collaboration. And I think with that, I think we reached the Q&A portion of the webinar.
Thanks, Andy. We've received a couple questions already. If you haven't done so, please send your questions through the panel on the right.
Let's see
We'll
here.
answer as many as you can before time is up.
Let's see if you're.
Can you give an example of fitting ISO 26262 into my Innoslate workflow?
Yeah. So beyond what I just presented on here, I think one good way to do that is to kind of make a document, kind of listing all the things you have to do, everything that's highly recommended or recommended. Kind of make a list of that, and then as you're doing your project activities, you can relate them to your activities. So then you can see that you're satisfying the different parts of the ISO process or ISO standard as you're going through your development process.
Thanks. How does
Mhm.
Innoslate compare with other ISO 26262 solutions on the market?
Yeah, I think I kind of looked around uh, to see what else is out there. I've seen a couple tools. A lot of them focus on certain areas of the V model process, such as requirements or some of the more design tools like evaluating those software components. I think for us, we're looking at it from a higher level, kind of having everything close together with our features. Um, I think we include more than that.
Great. General question about Innoslate. What's the best approach for someone to start using this tool? This tool has a lot of functionality, but
Mhm,
what is the learning curve and how can someone hurry it along? Great
mhm.
presentation.
Thank you. Um, I think a good way to get started, I think I brought it up before. We do have a guided tour. So once you set up an account with a free or academic or paid license, you can start walking through the tours that takes the time to walk with you through each of the steps like requirements, database management, configuration, that kind of thing. And beyond that, we also have a help center that we're trying to um, make more complete now. So then, if you have any questions beyond those guided tours, you can reference the help center and pick out what you need and see all the blogs that talk about um, helping you there. And there was one part I forgot to address. I was the learning curve. Learning curve. That's what it was. I think the learning curve is not as bad as learning some of the other SE tools out there. I know I used to do core back in my academic days, and that took the whole college lifetime to kind of understand still. But with Innoslate, I know it can take up to a couple months. And that I know for a fact because I came into the company during 2020, at the beginning of 2020. And I started as an intern and learning the tool, and I felt really comfortable using it. Just a couple months later, um, towards the summer, to start using it for more in-depth projects. So I think that's what we're looking at for learning curve.
Great. That looks like all the questions we have for today. We would like to thank you again for joining us. As a reminder, we'll be following up with you very soon to send you a link to the recording and the presentation slide deck. We hope you can join us for SPEC President Dr. Stephen Dam's next webinar, Enhancing Systems Engineering through Generative AI. This is an INCOSE hosted webinar where Dr. Dam will be the guest presenter on Wednesday, March 20th at 11 a.m. Eastern. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Have a wonderful day, and we hope to see you at our next webinar.
Thanks, everyone.